We're going to look at graphing a piecewise defined function. But first, we need to define what this is. And again, this is also known as a piecewise function, just a sort of piecewise defined function. So what is it? So first, let's talk about the why. We use algebra to describe some characteristics of reality by writing an equation that connects at least two variables. But what if that takes more? And by connecting, again, means when we write an equation or a function, we're connecting two variables, and it is possible to connect more than two. But what if it takes more than one equation? Because as we change the variable x, not a single equation can describe it, it being the situation that we're trying to describe, because the rule changes. I remember, a function is a rule, and somehow, as we move across, change different values of x, the rule changes. What I'm describing is a domain issue. The equation can only be used for a restricted domain. And what do I mean by restricted? Limit the domain of the equation to a certain area or really interval or range, however you want to think about it. So a piecewise function, again, I can't emphasize the part, it has to be a function, consists of writing a function that is made up of two equations, each one of functions, or more. So you have to have at least two, but you have more. Over, and now I'm going to write different things here, whatever seems to make sense to you. Non-common, or disjoint, or non-overlapping, domains. And this is the way it is written. Here's the function, the main function. And what we're saying is this main function is equal to not one, but one, two, in this case, three, it could be more, could be two. But this is the restriction. You have this information on the right, and this is informs reader / user of the restriction. For a particular function. So okay, so it looks something like this. Here's F1, but only use F1 when you're in this domain is this. Use F2 when the domain is this, to F3 and the domain of this. And these three domains are disjoint. They have nothing in common. They're non-overlapping. Okay. Now, the declared domain next to each function is critical in properly using this format. When you look at the tax rates for an income, it uses a piecewise function in verbal form or table form. It may not look like this setup, and in fact, it doesn't, but it has the same components. For example, if you make between 30K and 60K, that means that this is your domain declaration. If you're in this range, then do this. In other words, what's coming next is the function that tells you how much tax you owe, or how to find it. Okay, so here's the declaration, the domain, and then how to proceed if you find yourself in that interval. So let's look at an example here, evaluating a piecewise function. Here's my function, f of x. Here's the three equations that I have. And if I want to evaluate, for example, this function at f4, what do? Well, I figure out where is 4. Here's, this is only use this if x, if your variable, your domain is less than -4. Use this if your domain is between -4 and 0. Okay. Use this if your, again, domain is greater than or equal to 0. Well, 4 is in this part. It's greater than or equal to 0. So that means I need to use this rule. So there we go. So f of 4 is 16. What about f of -5? Okay, again, I search where's -5 here, and I can see that it's that first function. -5 is less than -4, so -5 is in this range here, this interval. So I need to use that rule. Of course, I'm still this correctly. I enter now -5 here. And what does that produce? Well, -5 plus 3 is -2. So f of -5 is -2. If f is -2.5, okay, so here at -2.5, I gotta ask myself, where is 2.5? So it looks like -2.5 is between -4 and 0. So in that case, I gotta use this equation, which is not equal to a constant. And what this says is no matter what you enter here into this function, if what you enter is between -4 and 0, the answer is always 6. So no matter what, the answer is 6 because we find ourselves here. Okay, so that's how you evaluate a piecewise function. You have to figure out where you are in this declaration.